But I won't lie, I spent a lot of time today editing yesterday's vlog, so that was what I did. Now it's time to actually get started on today's content. Today's content will just be whatchamacallit, implementing NESTEROV momentum within our RNN. NESTEROV's momentum, I really shouldn't be taking that. It really shouldn't take me that long. Hopefully, the only thing I'm a little confused about is because, so as I said yesterday, so NESTEROV's momentum, it's kind of like momentum. That momentum, it simulates the, like, if we look at it from a point of physics, it simulates the where the ball or where the gradient falls the fastest, and it directs the weights in that direction. And so that'll allow the weights and the weights to update faster, and then the error function falls much faster because it's going down the path of steepest descent. With Nesterov's momentum, it does the same thing. However, Nesterov's momentum, it makes use of foresight. So it tries to simulate the next time step, or the next, it just tries to simulate, okay, if the ball is here right now and it goes here, where in this position is the steepest slope that I can go in, and that's that. So it basically just tries to like read the future, and so that's how that works. Now, reason why I want to implement this and I want to practice it is because, so for a normal neural network, that just means kind of simulating through one future prediction instance, and then one future backprop instance. So backprop through time, it may add some complication to that. I don't know. It could be fairly simple. I don't know yet. And that's kind of just why I want to build it out in Excel first before we actually implement it in code. So that's the plan for today. Let's get right into it. Oh, also check this out. Guess what I got for you guys? Or at least maybe more so for me, just so I don't have to constantly edit it out. But watch this. Whoa. But no, this immensely helps. And it helps you guys kind of see what I'm doing as well. So what I'm going to do is I'm going to go ahead and I'm going to duplicate this. I'm going to call it NESTEROV. Oh, why didn't you guys say anything? I completely forgot. Guess what happened? So I trained this for another 1,000 epochs. Oops. Now I want to show you guys what has happened. It'll blow your mind. It blew my mind. So I hope you guys will be excited too. So first of all, peep the error. Okay. The error is only at 0.75, which is crazy. It means that it's learned a lot. And look at that. Look at that. Right? And this is what I find very interesting about momentum. So if we go back to now, again, you can make the argument that perhaps this instance or this simulation had a better starting point because it only started with an error of 5, whereas this instance here had an error starting point of, I think, 7.5. But if you take a look at it, and you could argue that this has just found a local minimum. But what I really like about momentum update is that, again, because it's simulating where the gradients will fall fastest, it looks for those points. And so you can see here, it found one such point, and then it fell, and then I think around here you can kind of see it. It then gets a little steeper again before it starts to plateau and before it starts to flatten out as it's getting more and more perfect. And guess what? It took us a while to get here, but let's take a look at the output. So time step 1 outputs an E. Time step, so you input an H, it outputs an E. Time step 2, you input HE, outputs an L. Time step 3, outputs an L. And whoa, look at that. Time step 4, it outputs an O, finally. Meaning that this network is now finally able to output the word hello. It can finally say hello. That's mind-boggling. So let's go ahead and let's start implementing NESTEROV's momentum update. I just kind of want to remind myself as to how NESTEROV's momentum works in the first place. Yeah, so what we can see here is that this whole section here, yeah, so if you can see here, this whole section here is basically looking at the X ahead. So the X ahead is the, again, it simulates, tries to get foresight, tries to simulate what will happen in the future. And then in that future saying, okay, you know, there are multiple steep paths that I can take right now, but let me see what happens once I actually go down those paths. Does that stay the same, or is there, you know, a path where in the future it's not as steep now, but it'll get much steeper in the future. And so that's what it looks for. And so in order to get that, you need to then simulate the inputs again, go through, pass everything through, feed forward, and then you also want to simulate what happens when you try to backprop again. So that is the annoying part about, yeah, that's the really annoying part about Nesterov's momentum. It kind of does like a half backprop simulation. And let me just pull up the CS50 notes. Oh, sorry, not CS50. CS231. Okay, so this is essentially the code. Actually, let me double check. Just give me 1 second, let me double check. Yeah, this is essentially the code that we will be using, even though no one really uses this notation in practice. I just find it much easier, so I just go ahead and I just use this. But so yeah, once again, we're just going to get a look ahead for x's, and then we are going to calculate the gradients for those look ahead, like I've shown in the Excel sheet, and then we're just going to calculate our v, which is our momentum variable based off of that, and then we're going to use that to update our x, which is our weights. So let's do that. Oh damn, what just happened there? I don't know if you guys saw that because everything zoomed in, but my computer kind of just spazzed out on me a little bit. So in order to do that, oh my god, we're gonna have to add more chaos to this. So then basically everything to the left of it gets copied, everything just goes again, layer 1, then we go to outputting it, and then we get the output, subtract, we got our output error, we got our output derivative, our output delta, and everything is as normal, kind of. Okay, we stop with the deltas, because that's all we really need. Yeah, I mean, it's not really, doesn't really change much. Okay. Yeah, I just have to do a better job at moving my mouse. It's a little shaky. So I kind of have to look at how to fix that, but unfortunately, that's what we're going with that today. Okay, so what I'll need to do is I'll need to go ahead. I'll need to copy all of this. And just make sure everything's getting copied. Our whole sheet, everything. I just need to go up. Yeah, I'll just need to delete this and need to delete all these momentum variables because I don't really need them. But yeah, essentially. Okay, I don't need this button. Let me just go ahead and let me just, sure, cut, why not? I will definitely paste you. Not. Okay, so then these weights will then use the weights, I'm assuming the weights in the future. Where are we at? Okay, so input stays the same, right? Yeah, input stays the same. These weights are, oh, okay, hold up. These weights are the old weights plus mu times V old. How the hell does that make any sense? X plus mu times V old. Oh, okay. I guess it's just the algorithm. I thought, so there's no learning rate? X plus mu times V times old V, gotcha. Okay. Okay, so that's essentially what we're gonna do, right? We're just gonna copy this. So we're gonna have our old x's, which are our old weights. We're gonna add mu times v. And because this is in Excel, we're gonna be using the old v for this. Okay, so old weights is actually not that bad. It's actually pretty simple. Again, remember, I hope I don't jinx it. Times, plus mu. I'm just gonna lock that in. Times, whatchamacallit. Where's that other? Oh, old v. So old v for weights 1. Okay, and that's it. Just gonna delete that. Gonna come here. Oh, this is for t minus 1. Gotcha. This might actually be my quickest episode yet. Again, I really hope I don't jinx it, but yeah, okay. So that's multiplied by that. Then bias will be the same thing, kind of. So bias will be, take that, we'll take the old bias, again using the same formula, old bias plus mu, I'll lock that in. Mu is going to be multiplied by the V bias 1, V old for bias 1. Okay, and that's our bias. Just 1, 2, 3, 1, 2, 3. Just double checking that they have the same, or they have the same columns, so I don't run into errors later down the line. Weights 2 will be equal to the previous weights. So the old set of weights plus, once again, I'm going to grab our mu lock that in, multiply it by here, V old for, actually, sorry, here, V old for weights 2, and that's that. It's DA9. Okay, just double checking that I haven't made a mistake. By the way, let me just double check that I'm doing this correctly. Yeah. Yeah, I could add the brackets, but what's that thing called again? Order of operations will do its thing for me. Okay, so weights 3, again, same thing. Let's go grab our old weights. And plus, I'm not going to grab the bias because the bias has, it's in a separate section, right? Mu times the V for delta weights, sorry, V old for delta weights 3. Okay. And then bias will just be, again, the old bias plus mu times our old bias. Where are we at? Sorry, our V variable for bias 2, which is this guy, this bad boy right here, and kaboom. Okay. So that seems to be working. And so then we pass in everything. Again, we're just simulating an instance into the future. What I need to do is you need to be equal to this guy now. Then I just need to paste you over to all these other cells. I think that's it, right? Only 4. Yeah, only 4 time steps. Okay, Shift F9, make sure nothing's broken. It seems to be broken. That multiplication looks okay to me. Previous hidden layer, that weight times, where's GE3? The hell are you getting GE3? Oh, okay, there, okay. And then this will be that plus bias. And so because it's grabbing R, I'm assuming this is just the old bias that it's grabbing. Yeah, it's the old bias one that it's grabbing. What we want it to do is we want it to grab the new bias one. So what I will do is I will fix this section with our new bias one. Okay. And we lock that in. Copy and paste for each of our different time steps. Yeah, I need to, maybe because it's my first time using this, but I need to get better at using that mouse. But okay, oh well, let's move on. Where were we at? Okay, so let me just double check that all of these guys are using that bias and that bias. So it's FJ30, this guy, so your raw output, plus FQ30. Yeah, it's FQ30, FQ plus that guy there. Let me just double check this previous hidden layer. So the previous hidden layer is taking GE23. GE23 is over here. And then it's multiplying it by Z6. How did I miss that? Yeah, that would have caused some issues in training. Damn, how the hell did I miss that? Oh, okay, I think I know how. Okay. Try like that instead. Lock. Why is it not locking? Okay, there we go. Copy. Paste in there. Paste in there. And Shift F9. I'm gonna have to use my mouse a lot so you guys can continuously see what it is I'm doing. That's gonna be. It's gonna be tough. I've spent so much time learning to use Excel without my mouse. It's gonna be really, really tough to use it with a mouse. Okay, F323 plus that, plus the bias up there. All right, we're looking solid. And then our sigmoid should be fine. It's not referencing any weight, so I'm not worried about that. Okay, so before we move on, let me just go to, let's say, time step 3, for example, and just double check. The weight checks multiplication, this set of weights, that guy, exactly what we want. Over here, what it's doing is it's taking that, multiplying it by that, that's what we want. Previous hidden layers, mult of GE, so that's previous activated output. And yep, the simulated forward or the simulated X ahead weights, which is we're in that section there. Hidden output will then just be the bias plus hidden raw output plus previous hidden layers output. That looks good to me. Then we have our hidden activation, which is sigmoid of that. Looks good to me. And then, oh, we're not done. Okay, so this just needs to be equal to this bad boy here. Oh, there's a difference. 6965. 7972. So there's a slight difference, which makes sense. This is a trained. I'm still using the trained weights from the neural network, so it makes sense as to why it's just a very slight change, because it's pretty much at the end of training, so it doesn't need to adjust or alter the weights too much. Okay, let's come here, and yep, it's referencing the correct weights. And then your output is taking this, which is our hidden activation activated output from the previous layer. That's multiplying it by the weights that connect the hidden layer to the output, and then we're getting our raw output. And then we're taking that, we're passing it through our softmax activation function. What is it summing? Yeah, I forget how softmax works a little bit, so let me just go remind myself. Oh, right, okay, yeah. Okay, so softmax, you gotta take the sum of these bad boys. Why does it not let me lock it when I hit F4 the first time around? What is wrong with this computer? Okay, yeah, looks good to me. This there, and those. If I hit Shift F9, okay, there we go. One of them is only. I'm gonna copy. Actually, I'm sorry. I'm gonna copy one, paste it, paste it, paste it. Here's what I'll do. Just bring this down. Enter. Come into here. Bring this down. Enter. I'm gonna copy that. I'm gonna paste it down there. The reason why is just so I can, oh damn. Oh shoot, okay. I need to lock that, move that over. That looks good. Need to lock that, move it over. Okay, looks good. Lock that, move it over. Okay, looks good to me. And then just hit Shift F9, and then I'm so proud that I know how to output ELLO for hello. Okay, so then new loss. Okay, it looks like it's taking, yeah, it's taking the correct. Looking at the correct places. Yeah. The old loss is just the previous total loss, and the new total loss is just the sum of those two. And okay, so now we're done with forward pass. Now let's start going through back pass again, or back prop again. So for back prop, if I remember correctly, one of the very first things that we did was we grabbed our, you know what, never mind. I'm not gonna do this in order. The hell, too tired for that. I'm just gonna look at it, see if it makes sense. Yeah, that makes total sense. It's grabbing from the right sections. What about here? It's grabbing that, transposing it by, what is an AV? Weights 3. Okay, so I'm just gonna drag this, to be honest. Go faster, my friend. This may have been a terrible decision. Man, this is so slow. Okay, here we are, weights 3. And then let me hopefully lock that in. Yep, I'm able to do that. Let me copy this and let me paste it here. Hopefully everything looks the same. Oh wait, what is this last part? JO24. A, B, C, D, E, F, G, H, I, J. Oh, okay. Somewhere back here. Delta hidden. Okay. Okay, so let me just double check the last time step. So it's our delta outputs there, multiplied by our weights 3 up here. And then we're gonna add the delta hidden. Oh my god. Which one was it again? Oh, I remember which one it was. I'm just trying to. Plus JL38, which is our delta hidden for there. Oh, okay, I remember why now. Oh crap, yeah, that's way too far down. Remember that we actually have these guys, the original delta weights. They've just been pushed far back down because of the way I implemented the way I implemented. Take one more row. The way I implemented this error tracking is that it adds a new row every single time. So the effect of that is it just like constantly pushes these other, I can't even find them right now, but it just constantly pushes down those other weights. So it can't be bothered. So they're kind of important. Okay, so this one's grabbing the delta hidden. No, it's not grabbing the delta hidden. This one's grabbing the delta hidden from the previous time step. So then this guy and this guy. Right? That's what it is here too, right? Yep. Once I see 4,000, I know it's referencing that thing all the way at the very bottom. I honestly can't be bothered. And yeah, delta hidden is on column DX. Oh, you guys can't see that. Column DX. Once I see that 4,000, I know it's all the way at the very bottom. No point in verifying and double checking. Okay, so I think all this works. Just double check once more. Transpose by these weights 3, beautiful. And then we are grabbing this hidden raw derivative. So that's taking that times HZ37. Or sorry, GE37 times HZ37. Okay, I think I saw it before I accidentally clicked away. Okay, yeah, we're just getting the sigmoid derivative. So that should be fine. Multiplying it by the output derivative. Okay. And delta weights 1 is, you know what? It's fine. All this is referencing is just an array of zeros like this, so it's fine if you're locked into that. Just make sure that these are what I want them to be. So ET37. Where's ET? Yeah. That's in this time step. ET37 plus this guy plus those sets of zeros. Those sets of zeros. Again, once I see that 4,000, I know exactly what it's referencing. This plus GE30. Okay. Previous activation. This is where, okay, so again, this is referencing those zeros down there, and GE37 is here, and then HT. Oh, sorry, this was HT37. Then GE37, again down there. And then delta bias. Again, it's referencing those 4,000, that vector of zeros. And this is that right down there. Okay, beautiful. Again, the vector of zeros plus the, okay, beautiful. And then delta hidden, whoops, delta hidden. multiplying IE37. Okay, I'm going to need to change this. And I think it's grabbing weights 3. Yeah, it's grabbing final output weights. Oh, weights 2. Oh, yeah, sorry, because this is for the hidden layer. Okie dokie. And I think I should be good to copy this and then paste it, paste it, paste it. And one thing I will do is I'll just go through those calculations once again, just for the, actually let me just do this layer right now. So it's grabbing that minus that. Yep, that's how that works well for softmax. M mult of that, GM3. What was GM3? Okay, you know what? I might have to start from here actually. So HT16 plus JO24. Not hard, you just have to grind through this. This is just really ridiculous. Oh, JO34 is there, okay. GM3. Oh, okay. Did I already update that? Huh. Maybe I did. Maybe I'm just so tired. Okay, so output derivative and then GE16. That is there. Then delta weights 1. That. This. And then IL23. Oops, I'm going opposite direction. Hold up. This is IL. This is IE. I'm looking for ET. Okay. Then delta weights 2. Transpose. This is IR. IE. And then we need what? GE. GE3. Okay. Oh, right. Okay, and then this one, just double checking really quickly. This one's referencing the hidden activation. You guys might think I'm taking way too long doing this, which fair, but man, if I don't do this, if I don't spend time doing this, I will go ahead and I will train something and it just won't work. But yes, I'm spending quite some time just double checking and opening up each and every single one of these formulas. No, not each and every single one, but just most of them, just to confirm that they're all working or they're all referencing what I would expect them to reference. Okay, so IW. One thing I'm looking for. Okay, found it. Actually, no. There's one more missing. HT. GE. GE16. There we go. Okay. Now delta bias is that plus the old bias. Sorry, that plus the old delta bias and the old delta bias plus the output derivative. And then delta hidden is just M mult of IE16, okay, plus FQ6, which is the second set of weights. Okay. So then for Nesterov's momentum in the future, that's all we need. Yeah, we don't need to add, we don't need to account for V and momentum. So in light of that, I will get rid of all of these guys. Bye-bye. And what I will do instead is I will confirm me that that's actually updating. What I'll do instead is I will now update our momentum variable. So our momentum will now be grabbing, so mu times AU 37. Okay, so V old plus learning rate times BF. So this would be the delta, weight 1 delta for the future. Okay. So that's the only change we really need to be making. Yeah, because the weight has been adding momentum anyways, right? Let me just come in here. Let me just double check. Our new weights, just take the old weights, and then they just add momentum to it. Okay. So now let's go into momentum. And let's just update this. So rather than grabbing CU16, which is, where's CU16? Hold up. Oh, yeah, right here. Rather than grabbing delta weights from here, I'm just going to update this to be grabbing delta weights from, oh boy, should have thought this through. Delta weights from here. But then the sad part is I'm going to do the same thing for this one. It's just because I'm tired. I don't trust myself. I know I'm going to make a mistake unless I do it like this. Okay, you know what? I have run out of patience officially. So I will just quickly do it with my mouse. Okay, so instead of DF16, we're just going to be grabbing delta weights 3. Let's go to that section. Okay, and then instead of grabbing DL7, we're going to go to delta bias 1. We're going to grab delta bias 1. And then instead of grabbing DR17, which is old delta bias 2, we're going to grab delta bias 2 from here. And, oops, where am I? That looks good to me. And then this will just be momentum plus old weights, right? Let's just double check. So it's 31 notes. So we did our x ahead. Then we grabbed our dx for x ahead. And so then x is equal to, yeah, let me just double check. Because it's like 10, so I need to like double and triple check things. It's just that's time of the night. This is just equal to, this is what, just the old weights? Yeah, so this would just be equal to old weights plus momentum. Okay. I think we're good. Okay, so now let me just reset our model. Set everything back to 0. Set everything back to 0. Reset our weights as well to random again. So for these ones, I'm just using I forget, I'm pretty sure this is Xavier weight initialization, but so I'm just going to set everything back, reset everything in our node network, set bias back to 0, set weights back to random, and then here we'll do all that at the same time, setting weights and bias to 0. Sorry, setting weights to random and bias to 0, and then I think we're good to go. We'll just hit Shift F9, change everything. Now it's outputting everything as an O. It's fine with me. I know it. I trust it. I know it will learn. Down here, everything's set as 0, so there's nothing I need to update here. And then again, let's just go back to the very top. Everything in momentum has been set to 0, 0, 0, 0, 0, 0, 0. Okay. Are we ready? Are we ready? I think we're ready. Actually, let me just do this really quickly. Let me just get rid of this, so it's not some other. Because spreadsheets act really, really weird once you start using like a whole bunch of cells. And so I just don't want this to be. Yeah, I can delete that. I just don't want to. Let me just confirm, double check that. Oops. Yeah, they weren't being referenced. I just don't want, because once the performance, or once this spreadsheet gets way too big, what I want to be able to do is I want to be able to optimize it and reduce its size. And so I will remember the first set of weights, or the first array or matrix of zeros that's all the way down here. I'll remember that, but I might forget the second one. So might as well just clean it up right now. Get rid of this. And here we update first with our new error. Where's our error? Oh. Okay. Okay, guys. Hit save on that. We are good to go. So let me just hit Shift F9, have it calculate everything. And yeah, I mean, as far as I'm aware, I don't really need to change much. Actually, I don't need to change that button at all. I think it does the same thing, right? It copies old momentum into here, and then it copies the same set of weights. The only thing that's changed is just rather than using this delta weights, all we're using is just the future simulated delta weights from our look ahead function. And all right, let me hit train, and I will see you guys. Actually, you know what? What I will do is, I think I'll end it there. I will train this for about 2,000 epochs, get started on some quick video editing. Hopefully I can at least get some stuff edited in the next half an hour or so. Train it for about 2,000 epochs, and because that's what it took for momentum to fully learn. And so I'll just do that for this as well. Might as well. I'm confident everything's going to work, and I don't need to do much troubleshooting. But if there's any updates, I'll just pick up my phone and I'll update you guys. So once again, thank you guys for watching. Comment below what was your favorite step, what was your favorite moment, what resonated with you, what was the most valuable, what was most useful, or if I got anything wrong, if there's anything you would like to see improved. Comment below, or just come say hi, really. But thank you guys for watching, and I will see you guys tomorrow.